What's up everyone, and welcome to the Intro to Data Management crash course. This course is designed to work through the core concepts of UCI's CS122A course, designed and taught by databases expert Mike Carey. Shout outs to Professor Carey, you're awesome. Where I discuss the basics of database design and get my hands dirty with actual database design and SQL coding assignments. The goal of this course is to give you a fundamental understanding of how databases work and develop your confidence in creating, querying, and modifying databases. So without further ado, let's jump right into it. So what is a database? A database is some way to store and organize a large collection of data. Databases usually model some real-world organization or enterprise. These organizations have entities, things with attributes like students, courses, Facebook users, and relationships, which are interactions or associations between entities. So to solidify this point, let's try to model a university. So we'll have our university here, and we might try to model entities like students, maybe instructors, and courses. Okay, so those are some pretty good entities. Well, how about relationships? So maybe we could have stuff like enrollment. So what would this be a relationship between? This would be students enrolling in courses. We could also have teaching, maybe. Teaching would be maybe instructors teaching students or instructors teaching courses to students, right? Regardless, this is kind of the thought process that goes behind modeling some type of real-world organization using a database. Okay, so now that we understand what a database is, what is a database management system, or a DBMS? A DBMS is a software system designed to store, manage, and provide access to one or more databases. There's a lot of functionality and support that DBMSs provide to stakeholders that we'll discuss later in this lecture. DBMSs are actually the focal point of this lecture, but why? Why not just store data in CSV files on your hard drive and call it a day? Well, users looking for a way to manage their database have several core goals they want to accomplish. First off, they want to organize the data so that its contents can be accessed quickly. Lots of times, data needs to be moved between memory and disk, which are very slow operations. So being able to do this as quickly as possible, especially as your dataset gets larger and larger, becomes extremely important. Next, they'd want to answer questions the user may have about the data by making queries to the database. Another core goal is to maintain consistency in the data when multiple users can access it concurrently. We'll talk about concurrency a little bit later. Another goal is to restore the data to a consistent state if the system crashes, right? If we have a request that's made at this point in time, and then the request is completed at this point in time, what if a crash happens right here? Well, what should we do? Ideally, we should be equipped to deal with this situation accordingly. Another goal is to ensure that only privileged users have access to privileged parts of the database, right? You don't want interns with access to classified information that only executives should be able to see. And when storing your data as regular files on your operating system, these goals are difficult and time-consuming to achieve. DBMSs, on the other hand, are designed to accomplish these goals. So, with these advantages in mind, when wouldn't you want to use a DBMS? I mean, it seems like there's so many upsides that can accomplish all these goals. Well, it turns out that there are a few niche scenarios where you'd consider not using a One of the main reasons you would consider not using a DBMS is if you had an application optimized for very specific tasks, or with tight real-time constraints, or with hardware limitations. Take, for example, a tiny microcontroller with like 10 megabytes of onboard storage. That microcontroller isn't going to be able to fit an entire database management system on chip, And generally, these types of apps won't use a lot of the DBMS's functionality, so having that DBMS in the system becomes a waste of storage space and can even slow down an app's runtime functionality. Another scenario where you'd consider not using a DBMS is with an application that needs to manipulate data in a way that isn't supported by a DBMS. This is kind of an abstract scenario, but if you have an app that maybe makes a really complex query to the data or manipulates the relations in a very niche way, you might consider searching for other solutions to manage your data. But for the most part, DBMSs are a great general purpose solution for managing, searching, and manipulating your stored data. So now that we understand why DBMSs are valuable, let's take a step back and talk about some concepts surrounding database design.